Section 8.3b is about products and quotients using scientific numbers. And in this case, we're going to multiply and divide these numbers and show you how to do that. Here we're showing multiplication of two numbers that are in scientific notation. And the way you do that is you multiply the numbers that are out front. So 5 times 2.9, and then you still do times 10, but you multiply the two tens. 10 to the negative 8 times 10 to the second. And you deal with those separately. So 5 times 2.9, so you see that's 14.5. And then 10 to the negative 8th times 10 to the second. Don't forget that when you multiply bases that are the same, you add the exponents. So this is really 10 to the negative 8th plus 2, which is 10 to the negative 6th. Now you might be tempted to look at that and say we're all done. But if you look carefully, we're not, because this number here in the front, it's not between 1 and 10. And it has to be between 1 and 10 if it's going to be written in scientific notation. So where would I like my new decimal point to be? Right here. And to go from new to old, I travel 1 to the right. So what I'm going to do is I'm going to add 1 onto my exponent of my 10 here. So this becomes 1.45 times 10 to the negative 5th. That is my final answer in scientific notation. Here's another example of multiplication using scientific notation. We're going to multiply the numbers that are out in front of each, and then times 10, and then we multiply the tens that are in the back of each one, and we'll do those separately. So 4.3 times 7 is 30.1. Multiplying the bases that are the same means we add the exponents. So it looks like 10 to the 6th. Now, is this number in scientific notation? No, it's not, because the first number is not between 1 and 10, so we'll have to adjust it. There's the new decimal point to the old, so we add 1. So 3.01 times 10 to the 7th. Now, if you notice, the directions say to write the result in scientific and also in standard, and I neglected to do this on the last one, so I'll do it correctly here. We need to take 3.01 and multiply times 10 to the 7th, which means we're going to go to the right 7 times. So this is really 30,100,000. So your solution should be in scientific and in standard. Here we're asked to evaluate and write the answers in scientific and standard. Well, this time we're dividing two scientific notation numbers. So the way that you do that is you take the number portions and you divide those, and then you divide the bases of the tens with their exponents. Now this over here, you can use a calculator to figure out what this number divided by this number is. So you get 0.245. Over here, when you divide bases that are the same, you remember you subtract the exponents. So this is really a 10 to the 4th power. So we look now and we say, is this in scientific notation? Well, the answer is no, because this number is not between 1 and 10. So we put the new decimal point here and go to the old. Notice we went 1 to the left this time. Because we went to the left, we'll subtract. So we get a scientific notation number of 2.45 times 10 to the 3rd. We also have to write the solution in standard notation. So 2.45 times 10 to the 3rd means go to the right 3 times, 2,450. Here's our last expression using division again. So we'll divide 6.4 by 1.6 and divide 10 to the 4th by 10 to the 7th. Well, 6.4 divided by 1.6 is a 4. And here when you divide bases, you subtract exponents, so you get negative 3rd. Is this in scientific notation numbers? Or is this a scientific notation number? Yes, it is. So that's my answer. And then 10 to the negative 3rd means we go to the left 3 times. So 0.004 would be the answer in standard notation.